Hello, everyone, and welcome to my channel where I teach MicroPython tips, tricks, and secrets. Today, I want to announce something very special. I just hit 10 million subscribers in binary, so 128. And actually, we've been growing a lot since, and we've been growing so much that I got myself a whiteboard, and we're going to be looking at that today for today's topic. And what is today's topic, you may ask? Well, today's topic is a fancy protocol called MQTT. And what MQTT allows us to do is to create an Internet of Things, an Internet of Devices that are all communicating with each other. And these devices can even be tiny microcontrollers because the protocol requires so little data overhead that we can use it on the tiniest of devices. So let's all head on over to the whiteboard where I can explain the protocol, explain what we're going to try to do with it, and get right into the code. So how does MQTT work? Well, the trick is with MQTT, you don't directly connect the microcontroller to, say, your phone or your laptop. You need a broker right here. What the broker's job is to do is to capture all messages that come out of any device and send them onto the device that wants them. Now, how does the broker know that? How does it know which device wants a certain message? Let's say we have the blue ESP32 over here wants to send a message to the green ESP32 to switch on its LED. Well, the way to do that is the green ESP32 will have a topic, what's called a topic in MQTT, and that's just a string, like a name, and that topic could be, let's say, /setMyLED. The blue ESP32 publishes on that topic, and the green ESP32 subscribes. And the meaning of these words, publish and subscribe, are actually sent to the broker. So the broker knows that the blue ESP32 wanted to publish on that topic and the green ESP32 wanted to subscribe. And what it does is it handles the trading of those messages. So it takes that message from the blue one and sends it to the green one. But also notice that you don't only work with two devices in MQTT. You can actually connect as many devices as you want. So for example, if you wanted to connect a laptop and control everything from your laptop in your home, for example, you could totally do that by also connecting it to the broker. But what is this broker? Like, where does it run? Where does it live? And the answer is the broker can live on any computer. It can run on your laptop. You can run it on a Raspberry Pi. You can even run it on a server on the internet. The choice is really yours based on your needs. For my example, since I'm just going to be teaching you, I'll be running it on my laptop. But if I were to do a home IoT setup where I wanted to connect every sensor and every light in my home all to each other, I would probably run it on a small Raspberry Pi and tuck it in a corner, and the broker would be passing the messages around. One last thing I do want to mention, the medium of communication between all of these is just good old Wi-Fi. So this is talking to a broker over Wi-Fi, as is everyone else. The only difference here is that they're using the MQTT protocol to talk to each other rather than HTTP as we are used to from previous tutorials. Okay, so let's get started right away. For our broker, we're going to use this awesome software called Mosquitto with 2 T's in it. So make sure you get the 2 T's there, mosquitto.org. And we're going to go click on download. If you're on Windows, get one of these. If you're on Mac or Linux like I am, we're going to use the command line to install it. So I'm just going to go ahead and close this for now. And just going to type in brew, install Mosquitto since I'm on a Mac. Remember the 2 T's. Never forget the 2 T's. All right. So for me, it was already installed, so not very much going on there. Before we can run it, actually, let me run it just so you can see what kind of output you get. So Mosquitto right there. Version 2.014 starting, using default config. Starting in local only mode. This is actually the most important thing here. So connections will only be possible from clients running on this machine. And that is not okay because we actually want to connect our 2 ESP32s here to our laptop and to be able to talk to each other, and they're not local to the machine. So we're going to have to dig into the config file and just change 2 settings, very simple, and I'm going to show you how to do that. And then we can get back to coding in MicroPython and connecting microcontrollers to each other. So first off, we're going to kill that. We're going to open in a text editor the Mosquitto configuration file. On Mac OS, it's in opt homebrew, etc., mosquitto.conf. It might be different for you based on your system, so just Google around. I'm sure it'll be pretty easy to find. And once we get in there, we see lots and lots of things going on here. I have no idea. That's fine, doesn't matter. Go to the very bottom of the file. So let me just show you the line numbers here. Go to the very bottom of the file and just add these 2 lines. So listener 1883, which it just means that we're telling the Mosquitto broker to listen on port number 1883, which is the default port number for MQTT, and allow anonymous true. So allow underscore anonymous true. That's actually super important because that is what allows us to connect any other device on the network to this broker, and the broker will allow that connection. It's kind of like a cutting down the firewall in a way. What's important though here, I must say, is we're just doing this because we're developing. Really, in a production MQTT system, you wouldn't want to allow anonymous connections, and you are actually able to set usernames and passwords and connect from MicroPython with that username and password. But just because we're developing for now, we're just going to set these 2 settings, make our lives a bit easier. So go ahead and do that and save the file, and we should be good to go now. So now when we run Mosquitto, we're going to purposely pass in. So -c means pass in a config file, and we're going to pass that config file in. And great. So as you can see, it says configuration file loaded from homebrew, etc., Mosquitto, etc., etc. And it's opening a listener socket on 1883. And it's not showing any message like it did before about not allowing connections that are not on the local machine. So we are good here. And what we're going to do is open up another terminal instance down here so that that Mosquitto broker just kind of run in the background. And let's just give it a shot. Let's see if this even works. So we're going to try it out before we get into MicroPython by just setting a simple subscriber and a publisher from the command line and seeing if they can talk to each other. Note that this would actually work regardless of whether we allowed local connections or not, because it's all on my laptop right now. So luckily for us, we don't need to write any Python script yet. The Mosquitto program actually comes with 2 command line utilities to do a publish and subscribe, and we're just going to use those. So let's just set a publisher, Mosquitto underscore, subscriber, publisher, subscribe, and you have to give it a topic. So V means just verbose, so we get to see all the messages that it logs. T means topic, and the topic, in this case, let's say we get a topic of hello. Simple topic name. And you see up here, it says new client connected from blah, 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 blah as blah, 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 very long address names. So this is just referring to the fact that we got this subscriber over here. So as you can see, the broker is kind of aware of everything. Like, it's aware of every new device that shows up on the network that connects to it. It will log a message for that. So let's get back down here. So we have a subscriber. It's not really saying anything. We need to open yet another terminal. And in this one, we're going to create our publisher. So we're going to go mosquitto underscore pub. And same as before, we're going to give it a topic. So we want to talk on the topic hello so that the subscriber can listen to it. And we want to send a message -m. My name is blah. Boom. There you go. Hello, that's the topic name, and my name is blah. And we can actually send a different message on the topic hello. So we can just say, how are ya? And again, on topic hello, we get the message, how are ya? So that's great. Our broker is working, our subscribers are working, our publishers are working. So now we can actually, now that we're sure of that, we can go into the microcontroller realm and try out things over there. So as you can see down here, I've got 2 ESP32s connected over USB to my laptop, just for power though. They're not communicating over USB. And these ESP32s are actually just the most generic, cheapo ESP32s you can get. You don't need to buy anything special. You don't need to go to the fanciest websites. These are probably about 10 Canadian dollars each, so even less than that in American dollars. And they work perfectly fine with MicroPython, and you can just install it using the regular instructions for installing MicroPython. So what we're going to do is we're going to have them communicate with each other. And the way I'd like to do it is such that if you press a button on one of them, it lights a blue LED on the other, and vice versa. So let's open up our Thonny editor and let's create a new file. One cool thing about Thonny actually is you can connect two ESP32s to it and just choose between one or the other. So they're not really connected at the same time. Just go over to settings to make sure you know which one you have connected. So if you go to tools, options, and if you go to here, interpreter, you see my interpreter says MicroPython ESP32, which is great. And then over here, it gives you a choice of devices to connect to down here on your port or web repo. So what you can see here for me is I have actually two potential devices to connect to. And they're just on different USB serial ports. So let's just choose one of them for now and stick with that. We'll see down here in our shell, we can do our regular Python coding, which is great. Okay, so we're working. Let's write our main file. So I'm not starting from scratch, just to let you know, if you see my previous tutorials, I do teach you how to connect these devices to Wi-Fi first. So before you write any main.py code, you want to first connect it to Wi-Fi using a boot.py and a secrets.py. Boot.py looks something like this, where you import your Wi-Fi name and password from secrets, and then you do a connection using the boilerplate code. If you don't do this, if you don't know this, or if you've never done this before, I will put a link down below to my previous tutorial which shows you how to do this, so don't worry about it too much for now. You can just visit that if you've never done it before. For now, I'm going to jump right into my main, and I'm going to pull in the MQTT library that is used in MicroPython, and it's actually called MQTT, where it stands for micro, like the Greek letter. But we don't actually want the entire library. We only want something specific, which is, so we're going to go umqtt.simple import MQTT client. We just need the client. So the client is what connects to the broker. It's a client-broker kind of architecture. In addition, since we want to work with buttons and LEDs, we're going to bring in the machine library, and specifically the pin. And also, as always, we always need our time.sleep. So we're going to do it from time import sleep. And what are we going to do first? So the very first thing is we want to test if we're even able to connect to our broker, right? So let's set up the broker connection. So to connect to our broker, we use the command mqtt client.connect, and it takes 3 parameters. So one is the client name. This machine can give itself a name. And since on the whiteboard earlier, I was describing it as blue and green, we're just going to call one microcontroller blue and one of them green, right? So this is the first parameter. Next is the broker address. So this is the IP address of the broker. One good thing about MQTT is that this is the only IP address you need to know in the entire protocol. The microcontrollers don't need to know each other's IP address at all. They just need to know the broker's IP address. So in that case, this is my laptop's IP address. And that is this on my local network. If you want to find out yours, at least on a Mac, you just do, IP, wow, I keep typing IPA. There we go, just hit IP. It seems like I've been drinking too much beer. But here you go, that's my IP address, and that's what you're gonna put in over here. Right? And lastly, you need what is called a keep alive time. So the way the MQTT works is it has this concept of keep alive, in which the broker basically is watching all the devices that are connected on the network and trying to determine whether they're currently connected or disconnected, right? So if you, example, unplug your microcontroller, it would be good if within a certain amount of time, your broker knew that it's disconnected, so it's not going to expect messages from it anymore, and it can like delete that connection handle. And the way we do that is with a keep alive timer. So basically we say to the broker, hey, my keep alive time is like 60 seconds. If I don't message you in about that much time, it means I've probably disconnected. And let's just say we set it to 60 seconds for the purpose of this tutorial, but you can tweak that number to any number of seconds that you like. So I'm going to create a client object. I'm going to call it MQTTC, which means MQTT client. And it's going to be of type MQTT client, which we imported earlier. And we're going to give it the name, which is blue. We're going to give it the broker address. And we're going to just say keep alive equals 60 seconds. Don't omit the keep alive because it's actually required as a security measure, and you'll find that it doesn't really work without it. Okay, next up. There's a lot of logic we want to do with buttons and LEDs and all that, but before we even get to any of that, let's just try something a bit simpler. So let's try just publishing something in a while loop, right? Let's not even subscribe to any messages. So let's just say while true. We're going to take our client, we're going to publish a message on a topic. So that would be, let's say, oh, this has to be a bytes object, by the way. So we're going to send it as bytes object. And we're going to say blue / button / 0. And we're going to send it the value of the button. So if you remember from our previous GPIO tutorial, button is just a GPIO. And actually, we should first set that up. So we're going to say the button is on pin number 0 in my case. For this particular device that I've bought, it might be different for you, but I have an IO0 button right on GPIO pin 0. And in fact, let's just encapsulate this in a variable name. So I'm going to cut that out. I'm going to call that button topic. And notice that since this blue is kind of like repeated from before, I'm just going to capture that. So we're going to say client name dot encode, and then concatenate with that with button /0, just to say it's button on GPIO 0. The encode function, by the way, if you haven't worked with bytes and strings before, it just takes a string and encodes it into bytes using UTF-8 encoding. And if you don't know all that, that's totally fine. Just think of it as turning strings into bytes. So we're going to publish on button topic, and we are going to send the value of the button. So how do we do the value of a button or a GPIO in MicroPython? Well, very simple. We just go button.value, right? But again, like I said, this needs to be a bytes value. And well, button.value will give you an integer, right? It'll give you a 1 if the button is high or a 0 if the button is low. But if you want to see it on our laptop, if you want to see it be printed out to the MQTT subscriber terminal, we actually want to send it as a string so that we can see whether it's a 1 or a 0. And so what I'm going to do is actually convert that to a string for that purpose. And don't forget, you got to encode it. So encode, so that turns it into bytes. And we can, that's it. We've published a message, and we can, let's say, sleep for half a second. Okay, so let's just do a quick recap. What we've done is we've created our MQTT client, and we've given it a keep alive time and connected it to the broker. We are creating a button GPIO and a topic to send messages about that button on. And then we're publishing it so that the broker can see it on this topic. And we're sending it the value of 1 or 0 based on whether the button is high or low. And we just do that every half a second. Sweet. Let us save that as main.py onto our device. I'm going to call that main.py. This file is already open in Thonny. If you want to save with this name, close the existing editor first. What is going on? Okay, sorry about that. I seem to have run into a strange glitch with Thonny, so I just restarted it and we seem to be good now. So okay, I've saved main.py. Let us restart the microcontroller by hitting Control-D down here. All right. Fantastic. An error. Attribute error. None type object has no attribute right. And this is line 134. Great. What's happened? Ah, yes, I've forgotten to connect. So let's go MQTT client.connect. That's all we had to do. Okay, save that. Control-D to restart. Seems a bit happier. And look at that. We get a new client connected to our broker as the name blue. So that clearly works. let's see if it's actually publishing its button value and if we can read that value. So I'm going to do a mosquitto underscore subscribe on the topic. Instead of hello, it's going to be blue/button/0. And here we go. Okay, cool. We're getting on topic blue button 0, we're getting 1, 1, 1, 1, 1. And that's because this is an active low button. So in this case, if I press the button, I don't know which one it is, there. Now we're getting zeros. I let it go. It's ones. Press it, zeros. Fantastic. Okay, that's really awesome. One interesting thing we can notice is if I try to kill this code, so I hit Control-C to kill it, we actually getting nothing down here, which makes sense. If I actually open a separate terminal and I try to publish on the same topic, so I say blue button 0, and I publish the message, hola, we'll actually get that message. So this is the trick with MQTT. You have to be really careful about how you architect your system because anyone can publish on any topic. There's really no control over it. And so it is up to us as the developers to make sure we don't have multiple devices publishing on the exact same topic and confusing us about what's going on. So just something to keep in mind. But anyway, we have our system working and it's really great. And this is all working over the Wi-Fi in my home, which is awesome. Now let's get to the next step. Let's add a subscriber in the MicroPython code so that when it receives its sister microcontroller's button value, it switches on or off the LED based on that, right? So I'm going to go back into Thonny and I'm going to now create a subscription topic. And how do we do that? First, let's set up the LED. So let me add some comments around here. So this is the MQTT client setup, just so we don't lose it. This is the button setup. And let's do an LED setup. The LED on my microcontroller happens to be on pin number 2. So I'm going to say LED pin 2. And this is an output pin, so you need to explicitly say that. So it's a type of pin.out. And in addition, we are going to create a topic for it. So in this case, the topic is, we're actually just going to listen to the other microcontroller's button. So we're going to subscribe to the other microcontroller's button topic. Let's do that. I'm going to call the other microcontroller green. So the topic is going to be green button 0. So whenever on the green button 0, we get a 1, which means no one's pressing the button, LED is off. When you get a 0, someone's pressing the button, LED on. And remember, we're getting these as bytes, which we need to decode into strings. So we're going to do that soon. Next thing we need to do is to create a subscription. But when you create a subscription, we need to actually set a callback function that gets triggered when a message appears in that subscription. So we need to do both of those. So let's start by creating the callback function. And the callback function is, we're going to call it blink LED. And it's going to take a topic and a message. And all your MQTT callback functions need to be of this format. It takes a topic and a message, 2 parameters. In this case, since we only have one topic, I'm not going to check the topic, but usually you would do something like if topic equals something, then do this. Otherwise, if it's a different topic, do that. For now, I'm just going to say if message equals 1. And actually, remember again, message is actually a bytes object. So we want to decode it first into a string. If message.decode is a 1, that means no one's pressing the button. So we're going to take our LED and just set it to 0. Otherwise, we're going to take our LED and set it to a 1 to switch it on, basically. That's the callback function. Here we can set up our subscription such that whenever we receive a message on the green button topic, we will blink that. We'll blink or not blink the LED. So we're going to take our client and we're going to say set callback to the callback we just wrote, which is called blink LED. And we're going to subscribe to the topic, to this topic here, green button 0. That's almost all we need to do. We have one more step. Just because we are subscribing and setting a callback doesn't mean all of this really happens asynchronously. So that's one of the things about the default MQTT library in MicroPython. it doesn't automatically run the callback function when a message is received. We actually need to manually check for that. And the method for checking and running the callback function, interestingly enough, is called MQTT.checkMessage, right? So we're going to MQTT client.check_message. That's it. That's everything that is needed to do what we want to do, which is listen to the other microcontroller's button and switch on the LED. Now, let's just do a quick recap. We have just created an LED on pin number 2, which is the pin on my microcontroller where the LED is located, and set it as an output pin. We also have created a topic on which to listen, which is the other microcontroller's button. Since we are microcontroller blue, the green one will decide when to switch on the LED or not. We created a callback function that when it receives a 1, it switches off the LED, and when it receives a 0, it switches on the LED. And we've set these up using our MQTT client methods. And finally, this is very, very important, you need to do a check message in your main loop. Notice that in this case, a check message will happen every half second, which is totally fine. And so what we're really doing is every half second, we're publishing the status of blue microcontroller's button and checking the status of green microcontroller's button. And so we can tell it to switch on or off its light, and we also switch on or off our light based on its button status. And we sleep for half a second. So that's that. Let's try to save it and run it, see if it explodes. Okay, so to run it, we're going to go to the bottom down here and send a control D. Seems fine to me. We're getting 1s. If I press the button, we start getting 0s, and so on. Very good. Now, of course, we don't really get to see this magic. Actually, we do. We could pretend to be the green microcontroller just for now and publish from my laptop a message on the green button topic just to test it out. So this is actually one of the nice things about the flexibility of MQTT. Like, anybody can publish on that topic. So when you're doing testing, you don't actually need all your hardware. You can just simulate it from your own computer. So we're going to do a mosquitto pub, and instead of blue, we're going to do on green button 0, and message, let's send a 1. And that shouldn't really do anything because 1 means no one's pressing the button. Let's send a 0. Aha, awesome. I hope you can see that in the camera. Yeah, so the blue LED is on. So perfect. The subscriber works. We can turn it off and we can turn it on. Great. We are so close. We are on the final leg of this. We just want to basically copy all this code, change all the blues to greens and greens to blues, and put them on the other microcontroller. And then we'll be able to kind of remote control each other. So I'm super excited. Let's just go for it. I'm going to go in here, grab everything, copy it. Then I'm going to go into options and change over which microcontroller we're working with to the other one using the Thonny interpreter options. So we're going to go down here and choose the other one, hit OK, and just close this file just to be on the safe side. New file, paste everything in, change blue to green so that we publish on green now. It's the other microcontroller. And we listen to blue. And everything else is exactly the same. So very simple to make changes. I'm going to click save, and it is going to save to MicroPython device. And again, you notice I've already set up boot.py and secrets.py here. So that microcontroller is also already connected to Wi-Fi. I'm going to save it as main.py. And yeah, that's it. Now let's restart it. Okay, and it seems to be running. We also see a new client connected from this IP address as green. So the broker sees it. Finally, let me create a new terminal and subscribe so we can watch kind of what's happening. Oops, mosquitto TT. Sub. Cool, let's subscribe to green button. Awesome, we're getting messages from green button, and if I were to switch it off, we actually see both. We're getting zeros in the terminal and the light comes on, the blue light comes on its sister microcontroller. If you go the other way around, if I press the button here, the blue light comes on its friend over there. And we also see zeros in the terminal for blue button. And finally, just to have fun, let's just do both of them. And check it out, they both work. So it's a pretty awesome, very robust protocol, very low overhead, works between microcontrollers and any other device. My suggestion is if you're ever making a big system where you can have this master node, like a laptop or a Raspberry Pi or some kind of central controller that is able to talk to all of your microcontrollers, such as a home Internet of Things system or a robotic system or anything like that, highly suggest using MQTT because it can get like a lot of fast messages, a lot of flexibilities with this concept of topics that microcontrollers subscribe to and publish to. And yeah, you can actually build out very complex systems just using this very simple, powerful concept of brokers and publishers and subscribers. So I really hope that you enjoyed this tutorial. I really hope it was helpful to you. It was really exciting for me to get these super cheap, awesome microcontrollers and do something so advanced with them. If you do have more questions or if you would like to learn more, please let me know in the comments below or on Twitter or on my website where I actually post all of my tutorials, not only as videos, but also as written articles if you want to reference them later. Finally, I want to say that if you enjoyed this, please subscribe. It really helps me because I get more understanding of what people's needs are and what projects they'd like to make so I can make the best projects. And also helps you because every time you join and you give your feedback, I make projects that'll help you accomplish your goals with MicroPython. Thank you so much for watching. Until next time, take care. See you. Bye-bye.